Okay, we are going to begin with chapter 1 here, and we're just going to start moving through the material. So to start with, we have... Okay, so the idea of chemistry, when we study chemistry, and this is not your first chemistry class, so chemistry is just a look at matter and the changes that it undergoes, and there's a lot of different changes that matter can undertake. This section kind of on scientific method, just kind of the way that we go about understanding um, the world around us. So everything, we go from maybe we see something in nature, maybe we see something in the lab, and we start looking at it, trying to understand it. We formulate hypotheses, we test it again, make experiments, try to figure it out. And you do that enough times, you eventually might develop a theory that kind of holds lots of experiments and lots of hypotheses into one combined idea. All right, so when we talk about matter, we're going to talk about a variety of different forms of it. And matter, basic definition, is anything that has mass and takes up space. So one of those things that, so you've got atoms of an element, so that's just like the smallest whole item of matter. And then you've got molecules, which are combinations of single elements or combination of, and then you can have molecules of a compound, which is made up of multiple elements bonded together, and then you can have a mixture of elements and compounds. And really, so atoms, these are the fundamental building blocks of matter. They're kind of the smallest whole items, and each element is made up of just the same atoms. Now you can have metals like strontium or calcium, and they're just going to be single atoms or in a metal lattice. But when you talk about like oxygen or nitrogen or fluorine, as an element, they're always paired together. Similar, like so, oxygen in that picture there has two atoms together. It's still an element, even though it's two atoms. And then for a compound is made of two or more different kinds of elements. You've got a variety of compounds there on that slide, everything from water to aspirin. All these ones are mostly organic, so you've got aspirin, and ethanol, and ethylene glycol. All right, and then when we talk about the basics of matter, the basic three phases of matter being gas, liquids, and solids. Uh, Gases, their volume changes as well as depending on the size of the container. So, and one of the characteristics of gases, the particles are in constant motion, very high speed, and they are very far apart from each other. Liquids, on the other hand, they still have energy associated with them, so there's movement and motion, but there's still some attractive properties to one another, and so therefore they stay kind of near each other in a liquid form. But in a disorderly way, they overlap and change position. And then for a solid or a crystalline solid, their solids are arranged in organized patterns according to just their bonding relationship and their size. All right, when we go to classify matter, so let's say we have a lump of matter and we want to classify it, the first question we would ask is it uniform throughout? Like, is it the same? If it isn't the same, then we classify that as a heterogeneous mixture. So it's made up of multiple different things. Okay, so heterogeneous mixture. If it is uniform throughout, so if it's the same, no matter if I took a sample from the bottom of the beaker or the top of the beaker, we classify that as homogeneous. The next question we would ask is, does it have a variable composition? And so if it's yes, so it has a variable composition, so it's made up of different things, then it would be called a homogeneous mixture or a solution, a mixture of two or more distinct compounds. And then if it isn't, then it's a pure substance. And a pure substance can be separated even smaller, and we can ask the question, can it be separated into simpler substances, broken down into smaller things? If it's no, then it's an element. Then you have a pure substance that's just a pure element, okay? But if it can be separated, so let's say you can break it down into separate elements, then you have a compound. So water would be an example of that. Water is made up of hydrogen and oxygen. When you go to separate it, like if you did hydrolysis, you could separate it into just hydrogen gas and oxygen gas, and so therefore water would be classified as a compound. And an example, going back to the homogeneous mixture or a solution, so sugar water or Kool-Aid, when you make Kool-Aid, when you mix that in there, take a scoop of Kool-Aid, you put it in water, you mix it around, when you look at it, it's homogeneous. It's the same throughout. If I took a sample from the top, if I took a sample from the bottom, it's all the same, assuming you don't have so much Kool-Aid in there that you have a bunch of sugar at the bottom. All right. Next, when we talk about properties, changes of matter, there's two real classifications of types of properties. So there's physical properties, and then we'll talk about chemical properties. So physical properties, these are things that we can observe without the substance having to change into something new. So when we find the boiling point or the melting point of a substance, so water, when you go from solid water to liquid water, it melts, but it's still water. It's still H2O. It hasn't changed. So that's classified as a physical property. And there's other physical properties that we can define. So density, mass, volume, variety of other things that you can see in your book. And then when we talk about chemical properties, the only way that we can know a chemical property for a substance is by observing it, but afterwards the substance is gone. It's actually changed. So the idea of flammability, corrosiveness, how reactive it is in the presence of an acid or in the presence of a base, those things would be chemical properties. Because if let's say you put a piece of metal in an acid and it reacts. Well, the acid has now reacted with the metal, and the metal is no longer the pure metal. It's now some new substance. So you now know that that metal is reactive to acid at some level, but you don't still have the same pure compound. Next, another type of property would be intensive properties. These are independent of the amount of the substance that you have. So if you have a large chunk of something, a small chunk of something, its intensive properties are the same no matter what. So like the density of rubidium is going to be the same whether you have 3 grams of it or 3,000 grams of it. Okay, it's going to be the same no matter what. Same thing goes for boiling point as well as color. Now, extensive properties, now these are things that depend on the amount of substance that you have present. So that would be like, the mass of something. So if I have 3 grams of copper, that is not the same as 5 grams of copper, right? So these are pretty basic things. Or energy, when we get into thermodynamics and energy, that's something that, depending on how much of the substance you have, you will produce more energy. All right, so when we talk about a physical change, these are changes in matter that don't change the composition of a substance. So it changes the state, the temperature, the volume. These are all things that don't change what the substance is. But a chemical change, these result in getting new substances that I already kind of mentioned. So combustion, oxidation, decomposition, synthesis, all those different types of classifications of reactions that we'll go into deeper later on. So a chemical reaction, when we define a chemical reaction, it's the combination of reactants to produce new substances. Okay, so reactants and products. So the example there being hydrogen and oxygen gas combining to produce water. All right, and compounds. So compounds, pure compounds, and this is an example right here of hydrolysis, where you run an electric current through water and you separate the hydrogen and the oxygen into their pure substances. And so a compound is a combination of 2 or more elements. Okay, how do we go about separating different compounds? So one form of separation is distillation. So when you distill something, different substances have different boiling points. And so the example in the image here is of you have a boiling flask, you have some salt water. What's going to happen is the water is going to boil off and you're going to condense it down, and you're going to have pure water down in the receiving flask, and the salt will be left behind because salt has like a boiling point of something like 2,000 degrees Celsius, where water has a boiling point of about 100 degrees Celsius. So it allows you to separate homogeneous mixtures through distillation. Another way to separate something is if you have a solid precipitate and a solution or in a liquid. The way that you would separate that would be through filtration. We'll be utilizing filtration quite a bit this year in the labs that we do. And then the last type of separation that we're going to talk about today is chromatography. And chromatography, the example being here is paper chromatography, where you have an ink mark there, and then you run some type of solvent up the paper, and depending on the polarity of the different dyes, so whether it's very polar or very non-polar, it's attracted. The dyes are attracted either to the paper, or they're attracted more to the liquid phase, or the mobile phase is what the liquid would be called. So if this was a water soluble pen, then we would assume that the paper would be the non-soluble portion. So non-soluble things would kind of stick to the paper more. So like that purple ink would be more non-soluble, and the blue ink would be more soluble, because as that water rises up the paper, the more soluble things kind of are attracted to the very polar water molecules. And that is where we're going to stop today. Oh, nice. Actually, we're going to continue a little bit further. And so now we're going to talk about units of measurement. So for units of measurement, we use a variety of units. These are the SI units, or basically the international standards that are utilized for measurement in science. The ones that we'll use the most are measurements for mass, and since in chemistry we use small scale, even though the international unit is kilograms, we typically work in just gram increments. We also use time, sometimes in seconds, and temperature is measured in Kelvin. So being able to convert between Celsius and Kelvin is something that we'll look at as well. And then obviously the amount of substance, the mole, is something that we are going to utilize quite a bit as we do chemistry this year. And yeah, so let's kind of continue on here. One thing to keep in mind is to be able to go within the metric system between a variety of different quantities. So to go from milliliters to liters, or from grams to kilograms. So being able to kind of move between the different increments fairly easily is really useful. So if you're not comfortable with, or aren't familiar with, oh, a centi is 100 of whatever it is. So if I have 100 centimeters, that means I have 1 meter. So kind of knowing how those increments go is going to be something that's going to come up throughout the year. So continue to kind of push yourself to develop and memorize those if you are not comfortable with the metric system. All right, another unit, and volume is technically not a international unit because it's a derived unit. So basically we use length three times to get volume. And so volume, the two increments we're going to use are liters and milliliters. And as you think through that, a liter is the same as 1 cubic decimeter. So if you had a cube that was 1 decimeter by 1 decimeter by 1 decimeter, then that's what you would have. And a milliliter is the same as 1 centimeter cubed. And that one is actually probably the most, that kind of combination there, that 1 centimeter cubed is equal to 1 milliliter. That one you're going to see by far the most. And that's where we're going to stop today. Really, I'm serious. And yeah, we'll see you tomorrow.